Good morning, good afternoon, and good evening, everybody. Welcome on into the Dragon's Den. My name's Digital Dragon, otherwise known as Luke, and I'm a 3D printing variety streamer here on Twitch. Does that mean, you may say? Well, it means I do everything from assembling and modifying printers, such as Bamboo X1 over here, to building printers, like you can see all behind us with the K3, prototyping, a beta build of a 0G Mercury 1, still in closed beta, um, borons, and everything else. And today we've been working on our VzBot. We will be getting back into the VzBot. The main structural build has been done, belts and everything. We're just working on our electronics installation. Welcome on in. Hey, Mr. Wizix, how are you doing today? Hope you're doing well. Fortunately, I was on a call, kind of running around trying to get everything, see if I can't get everything up and up. But interrupt. So yeah, welcome back in, everybody. You're doing well. Yeah, so we've got the KB3D hat on. We're wearing the Atomic Filament shirt, just because it was easy to grab in the closet there and I could wear it all day. The hat's because, yeah, I tried to do a trim. It didn't work, so we'll be going fully bald later tonight. The coffee mug today is our Tripods Garage. So John at Tripods Garage, one of our YouTube streamers. Definitely go check him out. He's been doing a lot of content on lasers. He's done a CNC plasma cutter. Does some 3D printing stuff as well. But he has done quite a lot of different. Get my stream deck over here as well. Might make things a little. So I was going back through and reviewing stream stuff on ModBot and Build Stream to see how they did some things, because once again, the wiring was kind of weird and just left up to you, and it is that way for a reason. It's a VzBot, and it's your VzBot, just like it's your Voron 2.4 or my Voron 2.4 Fey Dragon versus my Voron 2.4 Kyber Dragon. Each build is slightly different. They have their own unique personalities. That's why I name them. And you can do different things with the electronics, the hot ends and stuff like that for a VZ build. This is just one way that it can be done. And this is, you know, we are going to continue to use the electronics that are provided, which was the Mellow Fly board. I see Nero in the process of putting a Kraken on his, and he was going to try and swap out the Goliath for a tube, but it doesn't work because interference with the carriage. But that just goes to say there are options. You can do things. As new electronics come out, you know, maybe you want to switch over. Maybe I throw a Leviathan on here and run external 50 for the Z motors or for the A and B motors. It could always happen. You know, there's more than one way to scan us. What makes them rep wrap machines versus a commercial entity printer that is somewhat locked down. Yeah, we can do some cosmetic changes to it, but there's a different use case for this machine versus this machine. So anyhow, uh, in prepping for this stream, I realized the reason that my Loctite was not going up was just the simple fact that my Loctite's at the end. Like this is all the Loctite left in there. Okay, so hey, Tugboat, welcome on in. So I figured, okay, it was time to do some restocking. So I got me a couple new tubes of Loctite. So we'll open one up and throw it over here on the bench. Possibly be using it later on the build. I don't know. We'll see. So we'll get a fresh tube of Loctite up here on the bench. The other one I'll probably take out of the package and just store over on the wall. We got some new shears. These are going to be dedicated shears for up here to be able to cut things like plastic, possibly some wires if I need to, and other things. But this is going to be basically relegated to the 3D printing tool set. These are actual shears. Kind of like one of those things when people say if you're doing fabric and sewing, they say, well, what makes what makes those fabric shears versus leather shears? Well, the simple fact that it's never cut anything other than fabric or leather. You buy those, you buy fabric shears, which could be any type of scissors, and then you only use it for fabric because you use it with other things. It dulls the blades a lot quicker, and then you get ragged cuts on your fabrics and stuff. Same thing with leather. So these are going to be dedicated for 3D printer stuff. Now, if I need to open up a package, I'll grab the regular scissors or my hobby blade, but these are going to be dedicated for, maybe cutting and trimming some of the wire tracks or wires or other things like that. These will be dedicated for the stream. Couple of other things that I picked up that I knew I was going to need was a new set of crimpers because they wear out after a while, right? If you do a lot of builds, sometimes the teeth wear out. So I picked up a new one. That over there. So I did pick up a new one, and I don't remember what all I got. But we're going to just open up some things here real fast because, well, I need to get them out of the way to put other things over here on the stool. So, yes. So the version of the eye crimps that I bought, like for $3 more, I got the flush cutter. And I needed another flush cutter. I know you say, well, you need a new flush cutter like a hole in the head. Doesn't every printer you buy have a flush cutter with it? Not all of them, but most of them. But I'll say these have some pristine jaws on them because they're brand new. A lot of my flush cutters have some spot that's bad in them because I've tried to either cut spring steel wire or like a screw down, and I've damaged the jaws. So a lot of times you'll see me fighting with my flush cutters for that very reason. So those flush cutters are still pretty good for doing, cutting filament or cutting an edge of filament, something like that. But every once in a while, and let's be honest, the ones that you get that come with your printer are not the best set of flush cutters to start with. So if you do enough of these, go buy yourself a good pair of flush cutters or side cutters, whatever you want to call them. Go down to Lowe's or Home Depot and get a nice set. Somewhere, if I can find them again, I actually have a pair of, they're called lineman scissors from back in my military days when we were doing a bunch of things. So like I said, this is what I've been using. This is the iWis or iCrimp 2820M. So the iWis or iCrimp, I think iWis rebranded as iCrimp. This is a 2820M. This is good for all of your JST, DuPont style connectors. You may hear people refer to a engineering PA09. The problem with getting an engineering PA09 is there's two types. Meaning you can get the ones that are made in Japan, which are really good and really consistent, or you could get one that's sent from Taiwan, which is not so well. The iWis or the iCrimp, you know, it's proven to be well. It's held up pretty well. I just know that I'm wearing down the teeth because I've done so many crimps with mine over the, I think, year and a half, 2 years that I've had it and been using it, doing all my printer builds and stuff and rebuilds and rewiring. So I wanted to get a new one to have it as a backup or spare because I know I'm going to be getting into one soon. And then from the last stream, you'll know that we were using some M4x6 screws up here, and we were pulling those from my stash. M4x6s are working. I think I'm going to pull most of these out and replace them with some M4x8s just because it's going to get me a little bit more bite on them. And with this 3mm thick, you know, your 3mm thick plus a little bit of a gap trying to get into the head of a hammerhead T-nut. I think I want to swap these out with some 8s. I'll have to lay it down on its front and take these out one at a time, replace the 6s with 8s. No big deal. It's something I'll do off stream. And then, of course, I need to get some M4 nuts. And the interesting part is when I got these M4 nuts, I realized that I ordered M4 nuts not too long ago, which is interesting. I still went ahead and just reordered and got another set of them. But I have a feeling that in one of the boxes over here with the droid stuff, I have some M4 nuts. But because I know I'm going to be doing some more droid builds down the road, I figured what the hell. It's, you know, a couple of dollars to get some more nuts. So I might as well get some more M4 nuts. So that one, that one lock nut that I put here, I'm going to take off. And in fact, once again, these were M4x6s. I think I'm going to take those off and put M4x8s on. Because they're not fully flush with the back, so there's really not that much bite to the screws. So I'd really much rather, especially since we're putting some heavy components on there, I'd much rather have a good hold than not. So let me I'm going to go ahead and swap this out with the M4x8. So how's it going, Tugboat? Hope you're doing well. Hope you are doing well. Ah. You'll also may notice here that I changed up the way I was doing the Wegos. So I'll bring you in and show you that off in just a second. Let me get a couple of these screws swapped out, and then that one lock nut swapped out for a standard nut. Drop M4 nut, enter the print. I'm doing pretty good. I'm kind of glad that the day is over and I am purposely not looking at my cell phone. Let's just say the last day has put me on a rampage because of last minute emails and the desire to, oh, well, we need slides for a briefing in 2 weeks. Okay, great. So I was like, briefing's in 2 weeks. I don't need to jump on it right now. So I continued doing what I was doing because I was knee deep in another task, only to find out that, oops, what they meant was we needed these slides by tonight so that we could do the dry run for the meeting with the VP, 2 weeks ahead of time, which makes perfect sense to me. I just wish he had told me that like the hour and a half before when he first told me he needed me to do slides versus waiting until 4:30. So then I was up until like 8 o'clock last night online just doing work stuff. Not happy. That not happiness kind of bled in today a bit. In the last couple of, or a rough couple of days. I'm really looking forward to a long weekend, holiday this weekend. So we'll see if, we'll just see if that gets exciting in its own right. This is it. School is officially out as of yesterday. That is awesome, Tug. That is awesome. Now, are you in a traditional school season where you're out for the summer and you go back in like August or September? Because I know we've got a mixture here of traditional and year round, and it drives me insane because I can never tell when kids are out of school, in school, and they're all out at the same time. It throws me off. Hey, Da Vinci, how's it going? Welcome in. Yes, I'm going to take it as saying yes, you're out until the fall, so you're on a traditional school year. Oh crap, that's right. You're in Colorado. I don't think they don't do year round in Colorado, do they? So that is now redone. Like I said, we'll hold on to our M4x8 screws. We may get into those a little bit later. Keep our M4 nuts here. Our M4x6s, because we did use those in the build. Hopefully we have a baggie for those still. Let me get something set up. Oh, the other thing that I did was, I normally do this as well. I ordered a bunch of the standard computer 3-prong printer cables, PC or printer cables, whatever you want to call them. So I ordered a bunch of those. Partly because depending on how we do wiring, they did weird stuff with the wiring. Like they've got they have they have blue and red wiring, which I think international standard or UK standard would follow that, but it's just odd. Okay, there's a bundle of wire. There's two more bundle of the blue red. There's more than standard black red wire, 24 gauge step wire. We had some heavier duty stuff over here with spade connectors, but it didn't make sense on what we would use those for. And then, of course, we've got motor cables. We'll have to figure out the order of the motor cables. There's a little 2510 fan that'll go on the spool head. So we'll try and get into some of that stuff today. And of course, we have the blower that we'll install while we're in the back panel. So just wiring wise, it's kind of a bit of a head scratcher as to what they wanted us to use where. And the outlet that they provide, right, is an illuminated switch. Oh, we got an ad break in progress. Minute and a half. You graduated from high school in 1958. Well, I'll just say I was born in 1972, hence the Digital Dragon 72. I graduated in high school in 1990. Yeah, the year-round school, I know they have it here. They've got it in a lot of different states now. It's just really wonky. And then some schools, like the public school system, is like traditional, but like charter schools are sometimes year round. It's weird. But the outlet that they provide, it does have a 10 amp fuse, but it's a 3-prong 10, which means you can pick, you're either going to switch neutral or you're going to switch live or load. And the way it works is the center and the other silvery pin. So you would come out of the fused side. So this side would come here, and then it comes out and goes to the power supply. This one, which is the odd color, slightly shorter one, pen, will be used to provide illumination to the power switch itself. One, I could care less about it. Two, like I said, you got to pick which side you're going to switch. Now, I did notice that I've got a spare power switch. Oh, crud. I was going to say I've got a spare power switch, but it's not the one with the angled flange sides. It does have the double switching, so that you're running both load and neutral through the switch. Now the question is whether the switch is at least the same size, and I can just, take this switch out and put this switch module in, then we're good. If not, I don't know if this goes in and is a tight enough fit to just clip. and that would be a no. This would just slide in and it wouldn't hold in place. So we really need to see if we can take this switch out and put it in this housing, which will give us the ability to do the double switching. Then I'll just move all these wires over. Let me see. Get these undone. Of course I can. That would be too easy. Hate really yanking and cranking on. The worst case scenario, we'll start doing other wiring, and I may swap it out and just do one of these. But like this style with where we're switching both sides, I'll just get a new one and I'll just swap this out later. We'll have to wire this up today to keep going. But I will just order a couple of outlets. The big thing is, while there's nothing wrong with this switch, it's just going. And like I said, with the way they did the wires, I would assume they're expecting us to use the red and black, and really it should be different colors for the mains to designate the difference between mains and your DC voltage. Because once again, 110 will kill you. DC is going to shock you, but it's not going to kill you. Right? So the other thing I noticed, and I'll bring this up here on the screen now, is in the VzDocs page. Remember, we were watching the video. We were watching the video because on this main electronics page, there is nothing else. It just says, okay, here's an overview picture, blah, 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 the bomb, and then here's a video and the different sections of the video. And so we were going through, kind of scrolling through the video, trying to find things. Well, if you actually come over here on the left side, called the table of contents, you can click on like the all-wheel drive specific, which talks about some files that you would need. And then, hey, here's the Mellow Super 8 version 1.3 board. This talks about how you would set everything up and what comes in the box. It talks about the fuses and where you would put each fuse. Talks about the MOSFETs and you snap them apart and you install the MOSFETs, and there's no directionality. The driver setup, it shows you what your drivers would look like, and that you would do all four on the bottom two rows for the SPI, and you would do the one for your UART stuff. Now here's the other thing that I had to change. I'll say I had to change. See if I can't bring you guys around here. So 0, 1, 2, 3, 4, 5, 6, 7. I didn't catch it, so I wound up having to just move these drivers down one slot. There is a known issue on these boards with slot 7. So it said it's important to use slots 3, 4, 5, and 6 for your all-wheel drive systems. Slot 7 has an issue with SPI, so leave the most left slot open. So you don't use that last slot. You use the other ones. So Okay, Timor. You'll catch up in the reruns, have to finish up cutting the repurposed lab table tops. They're about 120 pounds each for your new printer stands. And yes, the frames are steel. Okay, so you're doing steel frames, and it's that, it was like that stone lab countertops that you were using. Cool. So I did make that change. Also going through here, once again, they're showing an older version of the 5160 expansion boards that use the wire versus the FPC connectors. Shows doing that. It shows the fan voltage selection. So there are jumpers next to or to the right of each one of our fans. In the upmost position, so if you're the closest to the drivers, you're in 5-volt. If you're in the middle of the set of 3 jumpers, you're at 12-volt. If you're on this side, you're 24-volt. So I'm not going to put any jumpers in yet because I haven't checked to see which fan goes where. So we'll have to figure that out and do that jumper setting as we're plugging things in a little bit down the road. Now we know how the board works a bit. We can start setting it up on the machine, mount the PSUs, the boards, and so forth. We are going to follow this kind of layout where the board's centered. We'll have our Raspberry Pi over on this side. What I did was I swapped out for these vertical Wago mounts. These I found, Steve Builds was using these, Steve and ModBot. So I decided to print these out. They hold the 5-slot Wagos just nicely. And what I tried to do was the black, or in this case, my nanotube gray color is the negative or the neutral. The colored brick, colored one, of course, we have the lime green is our ground, and the blue is going to be our load for our 110. Over on our 48-volt, we're going to have our negative and our positive. And on our 24-volt, we're going to have our negative. And this right now is going to be the positive. I know I'm mixing colors. Don't worry. Okay. I just used the colors that I had loaded up in the AMS at this point where I was doing the files. I need to throw, I've got some red ABS that I'm going to throw in there, and I'll reprint 2 of these. So the 48-volt and the 24-volt will have the same color Wago mounts. And I will either put a 48-volt, 24-volt, mains or something designating them. And our 48-volt is going to stay close to here. We're going to have one run that comes in, and then the other 4 come up here. I've actually thought about whether or not it makes sense to move these up to the higher DIN rail here. But the problem being is I'm going to have the wires for all of my X and Z motors. So I'm going to want a cable trough because I'm going to be bringing the other wires in here. That's where I'm thinking that these are probably going to be better suited down here. I'll do my one connection over from the PSU and bring the 4 up into a vertical cable trough and run them over. So it seems to make more sense that way. The 24-volt are going to be right here. We'll bring the 24-volt down and to them, and then these are going to come right up to the board because everything on the board is going to be 24-volt. The only 48 volts going directly into the 51. So I'm just kind of trying to position them close to the point where they're just going to be straighter runs. There is a spot right down here that I need to leave open because that's where my motor cable for the Z is going to come out and then get routed, somehow up to the Z motor. So we'll have to keep thinking about that. As far as our wiring, once again, everything that they show in the manual, this is used for the DC. So I could use this for the DC side, whether it's 24 volt or 48 volt. I think Steve and ModBot were going to try and use different colors between 24 volt and 48 volt. I don't think that's necessarily needed because these are the only thing that's 48 volt. It's easy to tell. Same kind of thing with my K3 build is everything on the main controller was 24 volt. And then I had a secondary controller, which was the Annex Engineering Constellation Supernova board that was running my TMC 5160. So that board was 48 volt. The other board was 24 volt. So it was pretty easy to keep the wires separate. So hopefully that helps. Yeah, so we'll kind of get into it. I haven't laid out any of the cable trough yet, partly because one, I haven't taken it out, and two, I know I'm going to wind up having to cut it. So at some point, we'll need to cut this down to size because it's too long to just go in there. And I know I'm going to want one along the bottom. And I saw how Steve Builds did his. And it was kind of, you've got shorts and longs, ends with the long. So I think he cut his kind of the same point on a short. And that meant that his long, right? No, this short would be the actual middle. He opened that hole up so it went around that bottom M4 screw so that this would stay flush against the bottom and would be lined up at the bottom. And that provides good routing to bring our 110 from our switch into our Wagos. We can jump right over here to this PSU. The other ones come down, go around and into this PSU. And then we'll have the connectors that we'll need to for grounding the bed, the load, and the for the bed, right? And our 110 bed stuff, cable chain will come down this side. So our bed will be coming through this left side hole, and we'll be able to go right into the SSR and stuff here. So it makes life a little bit easier based on how things are laid out, just understanding that layout. And I'm not sure if I will even bother to put a cable trough here or if I'm going to be okay with any cable runs that come from here to here just being visible, and then put some trough here to deal with, everything that has to come in for this. All right, so we'll see. I'll play that by ear on how I feel like doing that. And then an option that I have is I can either do a standard Raspberry Pi, I can do the Big Tree Tech i4 sled with a CB1, which this would take 5 volt in through a through the USB or 5 volt into the board, or I do have a an actual Big Tree Tech Pi board. And with that option, basically the CB1 is built onto the board, and this board actually has screw down terminals so you can power it directly with 24 volt, and it does the step down itself. So doing something like this, I would be able to mount that Pi here, and because I know I'm going to take all of these 24 volts to come up here, I can pull directly off the PSU and make one single direct connection to this. And now my Raspberry Pi, or my Big Tree Tech Pi based on a CB1, is powered directly with 24 volts. And I don't have to worry about any 5 volt at all. So I don't have to worry about a step down buck. I don't have to worry about trying to pull 5 volts off of this board, whether it's CAN bus or something else, because I can run it straight at 24 volt. So that is a viable option. And this little hat that's here, this is its IO to CAN bus. So this is a CAN bus adapter here. So if I ever decided that I wanted to put a CAN bus toolhead board on the Hextrudort, I don't know, EBB 36, I could potentially do that and run it CAN bus, which reduces the number of wires going to and from the toolhead. Again, an option that we can do down the road. This also supports CAN directly off of here. I say that, but I would have to look to see how they do CAN. Because this supports RepRap firmware and Clipper, I don't know if they're doing CAN or CAN FD. That is important because a Duet tool board or a Duet board does CAN FD, and that's not compatible with the standard CAN bus boards that we've been getting from like Big Tree Tech that we're using, SB2209, SB or an EBB 36 or EBB 42 board. Those would not work with CAN FD. So we just need to be aware and figure out if we ever decide to go CAN bus. I'm not thinking I'm going to do CAN bus on this right away, but it's an option that I have that I can do. I kind of like this idea. I've got 2 of these Big Tree Tech Pi boards. I know people have said that they've had issues with them burning out. I want to try it, and then if I need to, I can always drop back to something like this, which is a CB1 running on a Pi 4 sled. Power this using, 5 volt like normal, either through the GPIO or running 5 volt once again off the board directly through the USB-C connector. And the reason you want to do that is you get voltage protection here where you don't on the GPIO pin. That's why you try and run them through here versus through your GPIO. It works. And sometimes I'll run, like on the K3, I'm running through the USB connector for the Raspberry Pi, and I had to bring another 5 volt line in to the side because I was taking random disconnect errors, and it's because everything goes via USB, so there just wasn't enough voltage being supplied to run it. I guess for now, I'm going to use this. I'm going to decide. I might just throw this on here just as for mock-up purposes. So just for mock-up purposes, we'll have this on here. We'll kind of see where it sets and how it mounts. And we will be doing this time comes. the way I want to cut this material, I'm thinking I really want to take it to the bandsaw, like measure it and just bandsaw cut it versus trying to cut this material for the most part. So I think I'm going to hold off on actually running this. I can leave my wires loose, do all the finagling and mounting off stream, or at least the prep of these, and then we can come in and slap them on once we get things kind of laid out and understood how we're going to lay it out. So with that, I think it's just time to start getting into it. We've got a kind of a full layout, and this will be useful to figure out where we're going pinout wise on the board, what connects where. Plugging in the 5160s again, then hooking up the AC. This starts talking about running all of our AC. And that's what we're going to start with. Like I said, I'm not sure. I think I'm just going to use all this for the D side of the circuits. And I'm going to check and see if I've got enough of the appropriate wire to do my AC wiring. If not, quite honestly, my thought process was cut one of those new power cords that I just got and use the wiring out of that. Because I want to use 18 gauge for that. I've got green, blue, yellow, and white. Don't have a whole heck of a lot of light blue. Let me just sacrifice a cord. Might be for now. Like I said, I buy these in bulk specifically because I take them to shows. And I think I've given out like 4 of them to people at shows, and they sometimes they make it back, sometimes they don't. It's 6 one, half dozen the other. Get them 6-footers, you can get them 10-footers. These are 6-footers. Pretty standard thing. Just cut the ends off and then start stripping. Strip your wires back. Don't think my other strippers work on it. Won't be doing that one by hand. Means we just have to kind of do it a little bit at a time. Use those new flush cutters, and we're just going to cut the ends off. I know it makes people cringe when I do this. But like I said, I stock these for a reason. And I know there's these devices that you can use that will literally like strip the wires out. In fact, it's called the little stripper, wire stripper. Desktop powered. And you can use it to just slice right down the edge and be able to get your wires off. And so that's going to be our wire. I'm going to go through and work my way through here, going slowly so I don't cut too deep and cut the wire, because, well, that would be bad. Just trying to remove the outer insulating jacket. Careful and go slow, and you'll get all of your wires out. And the way you can do it is, rather than trying to do the full 6 or 10 feet, you just do the little bit that you're going to need to do your first run and just pull off your your insulation as you get to the wire and need the wire. Because it gets harder to pull the insulation off as you work your way through this. On your way to Texas for a weekend trip, sweet. That'll be nice. Yeah, we're I don't know what we're gonna do. My brothers invited us to come out and hang with them for the holiday weekend. Just don't know. We'll see. Depends. If Miss Dragon wants to go, then I'll suck it up and I'll go. But it also depends on how many people are going to be there. We'll see. Maybe we'll just stick around here and we'll continue to do yard work. All right, so I've got a little bit here. Just trying to get off. It's almost like a baby powder or talcum powder that's on there. Your 3 wires are normally twisted together. So we just need a little bit, and we'll start using the wire as we need it. And the first thing we're going to need to do is build our power outlet, right? So we need to set up the jumpers on our power outlet, which means we're going to need the our fade connectors. If I can figure out the right language and words to use. Forks. Where's my space? This. And we're going to need once again, we're going to need our standard crimpers, and we have some insulated spade terminals that will be very useful as we do this. So let me clear some of this stuff out of the way so I don't knock things over. These are insulated spade connectors. I want to make sure that they're going to work and not be like way oversized. Which for the main, good for the main part, but for the inlet, but the switch feels like it's a little bit too big because there is a size difference. Give me 1 second. I'm looking here and seeing not liking my They didn't give me insulated spade connectors. They gave me some pre-made ones that really don't want to work. And like I said, these just seem like they're going to be a little bit too big for the switch, but we're going to have to make them work. So they're here. I don't think I had any smaller non-insulated spades, because if I had non-insulated spades, I could always just put heat shrink over them, and it'll do pretty much the same thing. Hey, Shenanigans, how's it going? Hope you are doing well, my friend. Hope you are doing well. We are starting to work on our wiring. And we're having to basically wire up our whole printer. They do provide some wire, but it's pretty much just blue and red. And they do have some black wire, but it's thinner wire. And I would prefer to use 18 gauge wire. So this is 18 gauge. I basically took a computer wire and just cut it and stripped some back. And I'll continue to work my way around, taking more off as I need to. Trying to remember, is white the load? Yeah, white's load, right? Live or load. And then the red, or the black is the neutral, or is it the other way around? Didn't seem to hold very tight. Yeah, I'm doing good, Shenanigans. Like I said, we're just trying to get our wiring started here. We're going to start by wiring up our switch. And this switch has a 3-pin switch. And I'm not very sure reliably how to wire this up. I do know that the one off color pin on here is the part that would illuminate the switch, which I could care less about. So it's just a matter of the ground is going to come straight out, the neutral will come straight out, and then the load, I'm going to jumper through the switch. So I'm going to switch the load, and the neutral is going to just be a direct connect until I buy other switches and swap them out. Because I would prefer to use the one where we're switching both sides. I just don't have one of those here on hand, and the one that I do doesn't have the little I'll say the mounting ears. So we're going to be playing this game. This game being either not stripping enough and not crimping it enough or something. Always do the tug test to make sure that your crimps are good. You don't want to have bad crimps, especially on your 110. green. Once again, 2 of these wires are going to be direct connect over, and then one of these we're going to have to basically make a little jumper, then do a direct connect over. So easy peasy, got to do it. So do you have any plans for the long weekend shenanigans? Hopefully you'll be able to spend some time with your son. That's a good one too. So we're going to have the ground. Ground on one side. Black is the neutral, if I remember right. So that'll be the one that's not fused or switched. That'll be a direct connect as well. And then our other connection be the white, be the load, if I remember right. European IEP, China, AC, UK, EU. Singles, neutral. Okay, so North America, green is the ground, white is the neutral, black is the line. So I got those backwards. I want to switch on the line. I'll move the black to the line. White to the non-switch side, which will be non-switch, non-fuse side. So that'll be my neutral. Black, I'm gonna cut and recrimp, make her a little pigtail jumper. So shenanigans, what were you working on stream lately? Because you've been working on a couple of different projects. I thought you were working on a like a turbo fan or something like that. Yeah, like an actual turbojet 3D printed motor. You ever get that up and running? Okay. I want to see how this goes in there. It goes in there like that, off. One is towards the front, off would be towards the back. Works. I should have been wearing my crimping ain't easy shirt. Anything, this is going to be the day. Pull this through. Which will go like that. It will be screwed on with, I believe it's the M2.5 screws, but you know, they had some issues where one of them it worked with the M2.5s, the other one it took a different size. So these are 2.6 by 8. I'm gonna grab 2 of these. These are basically self-tappers. And they are flatheads. Or I'm sorry, not flatheads, but Phillips head screwdriver. Screws. See if these go in and bite. That barely bit, so I'm going to actually say we're going to use some M3 countersunk screws rather than those. Even if I got to provide them myself, we'll see. M3. Just trying to, we'll say, guesstimate which would be used here. The part does have, I'll say, countersunk drilling in it for the mounting. don't think I have any M3 countersunk screws, or at least not in here. And honestly, it doesn't matter. It's more of just aesthetics at this point. More for aesthetics than anything else. I'm using M3x6. There's enough depth in the printed part that you could do probably like an M3x18 or M3x20 if you wanted to. That's going to hold that plug in. Right like that. And then we'll come over here and we'll figure out the lengths that we need to cut to go to our ground, neutral, or ground, load, and neutral. And we'll make those cuts. And I think what I'm going to do, you don't have to put ferrules on. It's up to you whether you put ferrules on the connections going into a Wago, right? Wagos are rated to use straight wire, whether it's twisted pair or not. So you can run your Wagos or your wires directly into the Wagos, or you can put ferrules on it. I think I'm going to go ahead and do ferrules on everything, because I know when I go on my screw down terminals, I want to use ferrules. On my screw blocks, we'll use forked connectors. So it's just a matter of, it'll take more time to do it, but making everything look nice and pretty is not necessarily a bad thing. So be doing 18 gauge. Be our red ferrules. Probably going to need to order some more of those down the road. White or green. So I'm going to have my wire run down here. I can bring it down into the wire run and then pop it back out and come up. So I'll leave kind of like a little bit of a loop here to be able to do that. I'm going to cut this longer than it probably needs just to be able to tuck it away later on. Okay, I'm going to have to move things around. Be able to get in here easier. If you're going directly into the Wago, just know that you have to strip 11 millimeters of wire for the connection. And all of your Wago connectors have a silk screening on the side, which actually can be used to measure that 11 millimeter. If you're doing like what I'm doing here, and we're going to be using our ferrules, then it's just a simple matter of putting the ferrule on. Your ferrule is going to be long enough. I'm going to have to spread these out to get the connections in. Then we'll move them back together once we get the connections. And once again, this is a 18.3 power cord, so it's 18 gauge wire. Doing your mains, 18 should be plenty good. I wonder if I got some white ABS. So I'll reprint this one in a white ABS. Fine with the nanotube gray acting as the black. That's not gonna make me feel bad. But redo the neutral white. The line being in the black, that's perfectly fine. The other side we'd do in red because that would be our DC current side. We normally are red and black. There's our first three connections. Next connections are going to be from these Wagos and go down and basically come right back up and do the line, neutral, and ground on this side. So make sure I've got enough wire here to play around with. I think what my plan will be is to put the forked terminals on and get those connected to the power supply, and then come back and do the ferrule connectors for the other side. Legos. I'll get us one side, jump over. Now I need to do some forked connectors. Or I don't know, but I like the blue and the yellow green. Um, yeah, so the international standard would use it's a yellow cable with green stripe or a green cable with yellow stripe, one of the two. The blue and is it brown for for their color scheme, which works well. Just trying to set up to use kind of a known standard. So if I ever give this printer or sell this printer to somebody, they should be able to quickly and easily look at it and go, oh, well, that's that's the mains wire. Um, and I say that knowing full well that I'm probably going to be the next guy working on this wiring job as I'm trying to fix or do something and trying not to screw things up. And once we're done doing this one, we'll be doing it on the other side too. Again, we're just going to leave some slack, and it's okay to have some extra. We're going to be able to hide it in our cable tray. So I just need to kind of measure that out, give it a cut, and then we'll mount the cable troughs with the VHB tape. One of the other nice things of doing this is I can also come off my ground and mount directly to one of the screws here on the den rail, or we'll ground our SSR, which is on a metal mount attached to a den rail, which is attached to the back. So this entire back panel should be grounded, and we'll check for that, check for continuity of ground after we get all of our mains wiring run, just so that we can verify. So we're going to verify our the voltages on our two power supplies, verify that everything comes on at the 110 stage before we keep going down the way, because if we're not getting proper voltages, the last thing we want to do is plug in a board and then blow a board or components on the board because we were running the wrong, either undervolted or overvolted. They're mean well power supplies. They should be fine, but trust but verify. Why we always give a tug on our cables. Trust but verify. I crimped, but did I crimp well? Sorry, you're getting my head in the way here. Okay. What do we got here? We've got line load is the white. It is the electrolytic blue because it was already in the AMS, so it was just easy enough to grab it and use it. The black is the neutral. And then, of course, our green is our ground. I'm going to turn this slightly so I can get a better look at this just to make sure I got them underneath the little tabs. Still can't. One that's not fully engaged. Probably would have been a lot easier to do had I just bit the bullet and dismounted the power supply once I realized that I was working on the edge right up against the back panel. Okay. Great. Okay. Once again, we've got our 3 wires. We're going to bring them down on the other side there. Bring them around. Bring them up. Just need to try and figure out where we're going to cut these. And easy way, we're going to cut them there. And then I'll figure it out once again. First up is our ground. There. Barrels. And if you ever cut your wires and they're too long and they extend out the end of the ferrule, crimp the ferrule. Grab your flush cutters, go right to the end, and then snip off the little ends. Make sure to protect your Mark 1 eyeballs if you're, from all of the little slivers that'll go flying. There's the first one. Our load is next. Figure out about where that needs to come to. Like I said, giving it some extra length is perfectly fine. We'll have a cable trough. It'll all look good when it's shoved in the cable trough. And it gives you an option for later on if you need to cut some wires or redo some wires. You might have enough wire to do something else. And these will slide around, and when we're done, we'll slide them all together. We'll be able to slide them together and make them pretty. Okay, so there's one power supply. Now we need to make the other power supply and run it over. Just clear off some more of our insulation here, or if you really wanted to, you could keep it in here. Strip off some ends, figure out where the link's going to be, strip off the other end, and you can leave this jacket around it if you really want to. Once again, we're going to be putting it in a cable trough. So do the level of wiring that you feel comfortable with and is necessary. Yeah, and Tugboat, I apologize. This last day or two at work has been pretty heinous. And I have not gotten down to the post office with your box, but it will go down tomorrow, heck or high water. I know KB3D was working on the bill of materials to get stuff ready to ship out to you. I'll ping him tonight and see how far he is or how much further he has to go. Posted a message. I got my Millennium Mills Milo kit in. That's sitting in the back of my mind, chomping at the bit, wanting to. Sitting in the back of my mind, going, Milo, and I am struggling and fighting the urge to take that out, show it off on stream, because I know as soon as I crack the box, I'm going to want to start trying to do some assembly and stuff like that. And we're not there. Should not be there. So trying to be good. Stay focused on this project. That, and I so badly want to do a one of the wire EDMs as well. Rack Robotics. Need to work that Ender 3 Pro. Don't, it'll atrophy. Is the This will be a little long, but like I said, we're going to get it in the trough, kind of make it look like that. So perfectly fine. So I cross my stream. Neutral, which is white. I'm going to regret cutting that. Oh well. It'll all work out. And I will say you all didn't catch the one thing that I did that was wrong, but we'll fix that here in a second. Yeah, I'll say I've been printing, but I feel like I haven't. I've been printing a lot, but I feel like I haven't been printing as much as I should be. I still need to ramp up my Toys for Tots stuff, but normally I get those started after Murph anyhow. So the fact that I'm already started, you know, I am technically ahead. But I've got some of that stuff started. As I was mentioning, I got the Milo kit in, so I started looking at, all right, what do I need to print? I'm going to start printing stuff in the order that I'll need it. Then just continue printing stuff. While I have my screwdriver out, I am going to undo two of these wires because I did the load and the neutral backwards. And I'm just So once again, white is neutral, black is load. So we need to swap these two wires around on this side. Hey, Maker Viking, how's it going? Welcome, welcome, welcome. Hope you're having a great day. We are working on the initial wiring. We've got some of the base electronics laid out and in place. Now we're going to start wiring some things up and do a little evaluation of things as we wire it up, which means we've got our plug installed. We've got our power supplies wired up. Before we go any further, we want to verify a few things are working. So let me, I want to say fully put some things away, but get some additional bits of metal off the workbench. Actually finish wiring of the last item because that would be bad. Then we're going to do power on of our power supplies. We'll validate that their voltages are correct. Validate our ground. Tired but good. Had a day getting interviewed on the next layer, among other things. That's right. You were doing the interview. Very nice. Very nice. Okay. So we've got our ground, live, and neutral. We've got both of the power supplies plugged in, ground, live, neutral, ground, live, neutral. Always good. We've got them in the correct order. Got a little bit of a service loop down here. We're going to put our cable trough down here a little bit later. Once I cut that to size. Ground goes to ground. Our neutral goes to neutral. We are switching the live, and the live goes over here to the live. So that should be good. We're going to plug in the plug. And on the count of 3, we're going to see if we let out any magic smoke. Any bets on whether or not we let out magic smoke? And this is why we're doing it. If we're going to do it, we're just going to burn up a power supply and nothing else. That's why nothing else here is plugged in, powered on yet. So we're trying to minimize any potential for damage. So at this point, we've got our AC wiring done, except for, of course, running load to the SSR. I'll do that later. The way I've got the SSR set up is our load side is facing down. Our trigger side is facing up because I'm going to be coming off the bed to the trigger, and off the load, the load will be at the bottom. And we do that specifically because that'll keep all of our 110 down on that bottom row. Okay, so we're going to flip the switch, right? Got an ad break. So we're going to wait for the ad break to finish, because if I'm going to put sparks out, I want to make sure that everybody can see sparks. So we're going to be doing in the ad break. Again, we were drinking out of our Tripod Garage. This is John from Tripod Garage. Always a good dude. While we're waiting, we'll go ahead and get our multimeter out. And everything plugged in. No sparks, please? Yeah. No sparky sparks. No sparky sparks. Okay, 3, 2, 1. Ad break's over. Everybody's back. Okay, everybody. Not sure who all's out there in the Dragon Den land, but we are getting ready to do our first initial power up. All we've got right now is we have our outlet wired, and we have both power supplies wired up. That's it. We're just going to power everything on, make sure that we get lights on our AC power. Then I'm going to check the voltage output on both of these, and we'll go from there. So I'm going to flip the switch now. Okay. So the light flickered, but that's relatively normal. I have a light on the 48 volt and a light right here on the 24 volt. Bring you guys in here and show you that. So light there, light there. Okay. Now we're going to want to check our DC current and check both of our power supplies, which is going to be a little bit fun. So we're going to go to, what are we going to? For voltage check. DC voltage check here. And wish I had a way of hanging this. If okay. This way. Positive on the left, negative on the right. Sure, I don't. Oh, a second. Need to make sure I don't ground these out. Positive, negative. You guys can see that I'm getting 48.2. Got 48.2. We're going to do the same thing over on this side. and 24.1. So we're good. We're reading good. Now what I'm going to do is I'm going to go over to continuity. And I want to check continuity. So what I want to do, probably would have been easier if I grounded that. Let me do that first. Cut that off. Cut this off. Let me ground this to the DIN rail. To figure out which side would be the best or easier side to work on. This. Need a ground wire that will go. We can make this one. Terminal on one side and Wago on the other. We're going to ground our SSR, and because we're going to be grounding it and it's going to be metal to metal on the DIN rail, and the DIN rail is screwed through the aluminum sheet, we should have full common mains grounding through everything to the aluminum sheet. So if everything goes right, we should be good. There. Ground this on the load side of the chassis. Okay, so we're good there. We've now got a ground to the SSR, which is attached via a metal bracket to the DIN rail. The DIN rail is screwed into the back. So we should have a common ground plane between both power supplies and everything there. So once again, we're going to power on. No sparks. We still have 2 lights. We are going to go back into continuity mode, and when we touch, get something, get a reading. So what I want to do is the ground. I'm going to touch ground here. And I'm touching my panel and I am getting a reading. So how easy that is to tell. So I'm touching the ground of the 24 volt power supply and the back panel. And I'm getting a reading. Still doesn't look like you guys can probably see that. So I'm on the ground, touching the back panel, 0.3. I'm going to touch the other chassis, 0.3, and that's the other power supply chassis that I'm touching. Okay, so the entire back panel is good. If I touch, the den rail that the top boards are mounted on, it's 0.3. So our ground is good and continuous. I'm curious. So this is touching the bottom plate of the printer. This is the CNC'd bed chassis. So right now we've got good ground continuity everywhere. Yeah, I'm not getting it on the aluminum extrusion, but that makes sense because the aluminum extrusion is like painted or anodized, but all of the bare CNC, I'm getting a ground to. Or not a ground, continuity to. So good there. So I think electrically so far we're good. We know we're getting 24.1 on our 24 volt and 48.2 on the 48 volt. We've got our we've checked for ground continuity and we're good there. We obviously our mains is working because, well, we've got power, so that part's working. What else? I think at this point now we're ready to go ahead and start doing the rest of our wiring. Of course, once I pull the plug. Put away the multimeter. Hopefully we won't need it. The motor cables are pre-made. I'm going to assume that they are properly pre-made. And if we wind up that is not the case, then we will we'll have to break the multimeter out again to figure out what the correct wiring order would be. But so we've done our AC wiring here. We got no sparks. Once again, this is going to get cleaned up once I cut the cable trough to size down here. We'll bring this down, run it nicely through a cable trough, pop it out. We'll take this and shove it in the cable trough. So this will get niceyed up once I cut my cable troughs. And then I think I'm going to run wiring, and then we'll figure out the next step. So we still need to do the bed. I tend to wait and install the bed until the last minute. We can run our bed wiring right now, because we're going to do Wago mounts on the bed. I've got those printed out. They're, good kudos again to Steve Builds for designing a Wago mount. And these will take 2-pin Wago mounts, and we'll do like power in. We'll do the power in, fuse to jump between this one and this one, and then the power leg to the bed, the neutral in, the neutral from the bed. We'll have our thermistor, and we'll have a place that we can do a ground wire. And the way this goes is this is basically going to sit at the bottom, and we're going to have these clips that we'll put heat sets in, and we'll just run screws up from underneath and clip this underneath the bed rail. So I'll show you that in a little bit once we get there. Hopefully we'll get there tonight. There's some more wiring that I can do here. Well, I guess actually we can do some of that wiring now, because that'll be the 110 side of the wiring. I'm just not going to do the, I'll say the bed side of things just yet, because I don't want to do, I don't want to deal with adding the weight of the bed to the carriage and stuff. But we can definitely mount this. We'll have to do some, like I said, we'll have to do some heat set inserts real fast. Sure if we're going to use this just yet, so over there. Let me set this down on the ground real fast. We'll bring our heat set machine up, do the heat sets that we'll need so that we can do that clamp. Just a couple 4 heat sets. Everybody's pretty quiet today. Are we just getting ready for the long weekend? Being quiet, getting ready for the long weekend, or what? So the way these work, they're going into the back side, so that when you do the screws, you're screwing through the plastic and into the heat set. So you're pulling the heat set further into the plastic rather than standing the chance of pulling the heat set out. So you just drove through Colorado Springs a little bit ago. Nice. Yeah, my oldest son still lives there, over off of Powers. I'm assuming if you're driving down, you're going down 25, right by the Air Force. this cool off and let these cool down some. So I tend to buy these in the bulk boxes off of Amazon. I keep ones, twos, threes, and fives. I haven't had a reason or excuse to use fours yet, so I've never bought the fours. But these are the Wago 221 415. So this is a 221 400 series. So the one would be the 401, the two would be the 412. It's just the different style connectors. Oh, we got all of those in there. They're seated down in there really nice. They're not going to come out that easily. These up. No idea what size screws these should be, so I'm just going to hold the parts together and do a quick measurement. Roughly 16, so an M3 by 16 button head should work. I think I have some of those. Not silver though. Have well, we're deviating from the color scheme. Four M3 by 16 button heads. Run her back up here. And once again, this is, we're going to put it on the back side here, but basically it's going to sit underneath. Run the clamps on it. That'll give us our mounting point. And it's just going to go on the back here, right between the middle of this X. Need my run this in. loosely by hand for driver. Hey, Glendon, how's it going, my friend? Welcome in. Welcome in. We are trying to fiddle with some things. In this case, the fiddling is with some M3x16 screws to clamp these parts in. Part that we're working on right here is a part designed by Steve Builds that allows us to mount a set of Wago connectors to enable us to more easily connect our bed printer. Yep, we're mounting Wagos. When I can find the screw that I'm trying to be. One of those things, if you have your bed too high, then it becomes problematic. If you have your bed too low, it's problematic. Really just like know, hey, the bed's in the perfect place to be able to do things. Once again, this is a printed part by Steve Builds. It is going underneath the heated bed, so we want to make sure to use a heat tolerant filament. So ABS, ASA, PC, nylon, all the glass filled and carbon fiber derivatives of those. Okay, so that part's there. Now, the other thing that we got to remember is we're going to have our Wagos in here. The 4 holes that are on this bed is where our bed screws going down to hold our bed to allow us to level our bed. So we're going to have to come out of our Wagos and our wires are going to have to come around, go up into our cable chain, down through this side slit hole here. And that's where our wires are going to head because the cable chain. Not sure. I didn't see any type of printed part that he added over here to allow for cable management. So I'm not sure if he just did like a zip tie, how he did it to do his cable management over there. I don't think he did just a zip tie. That does not sound like a Steve Builds thing to me. So I may have to look and see some more. But I'm like debating, do I run the wires or not? And the reason I'm saying that is because these I use the TPU grommets down here, and I'm gonna have to fish the motor wires through here and everything through here. Just adding that grommet kind of makes the whole hole a little bit tighter. All right, cool tugboat. So going through and looking at the manual, it does talk about very important to properly ground everything. The distribution blocks I use for ground have a passage to the den rail. So those are automatically also grounded once a block is put on them. You can see I also grounded the top den rail and the wire on the bottom middle slot connected to the bolt holding my back panel to the frame. This way the entire frame is also grounded. Also important to run a ground from bed to our distribution block Wago so that the bed is properly grounded. We are, after all, running AC through the bed. Don't want to shock our correct. That's what we want to definitely do, is make sure that we route our mains cable down through here, bring it around. Our cable chain is going to arc around like this, bring it out, come over and go into our Wagos as appropriate for the bed. Like I said, I'm going to hold off on doing that until I start running wires, because I think what's going to happen is our 2 motor wires on this side are going to come down through here. 2 motor wires on this side are going to come down through here. There's a slot in the center that's very, very tight right now. I might have to take that grommet out. That brings the wire for our Z motor in. And then our umbilical is going to come down, and our umbilical wires for the hot end. This is the big hole over here. This is going to get interesting. So the big hole, this is going to be for the CPAP, where the CPAP is going to suck air in, and then the air hose is going to come from here up to our tool head for part cooling. Which means this hole right here is the place where all of our umbilical wires. That's going to be the wires for our extruder and our hot end and thermistor wire. Which there's no way that's getting through there. So I'm going to have to figure out how Steve Builds and ModBot and Nero did theirs. I think Nero did his because he didn't use the exhaust fan at all. And so he could run things through one of the exhaust fans. But the other thing we can do is, this is going to be our 48 volt distribution coming up to our 5160s. So okay, so it looks like they're providing power directly from the power supply. Okay, and yeah, okay. So yeah, we're gonna actually run our Wagos for our power supply to everything up here are gonna come from right here. This is our 24 volt. This is our 48 volt. So what we're gonna do, whoops. This is our 24 volt. This is our 48 volt. We're going to bring our 48 volt stuff up here. We'll run one connection from here to our 48 volt Wagos down at the bottom. This is our 24 volt. I need to pull 24 volt from this power supply over to this set of Wagos. I may bring it down through the same trough as my 110. Then everything from here is going to come up to the board. We'll have a connector for the bed that'll come from here down to the input side down here to trigger our bed SSR. And that doesn't need to be, like crazy wire. Like, this is way overkill wire size. Like, with the amps that we're pulling and the distance that we're pulling, we're under 2 amps at 48 volts. This is kind of overkill for what's needed. Can't tell. Is this 2 different? Yeah, it looks like I do have two different size wires here. I think if I can see some writing. So the blue wire just has the DRRV 300 300/500 volt. Doesn't actually give me the wire size. Red's the one that I think gives me the wire size. Which I just cannot read. Small black lettering on yeah, small black lettering on red, which by the way, I'm red green colorblind, does not help. Yeah, and that one, the red one doesn't even give the wire gauge size either. The heck. Now there's a part of me that just wants to toss this, but I think these two are better engaged than this. So this is probably 20 and this is probably, could be the 18 gauge. I'm going to use this wiring to make my runs up for the 48 volt, 24 volt. I might use the same color wiring, or I may just use my own wiring to be able to show the difference between the two the two different voltages, make it a little bit easier to see. This part is going to be heading to length and stripping barrels. Means this stuff can go somewhere else for now. Okay, so I'm going to have a seat doing it. And how are they running? Look, they were using black and blue, and I was given all black or red and blue. Sweet. Assuming that the yeah, I'm assuming that I'm going to just grab all of my uh, my wire and use it, because that way I don't get frustrated. I'll use this on some other project. Okay, so we're going to be using, for this we can use 20 gauge. Or 18 gauge, 20 gauge, 3 gauge. 20 gauge. Oh, that's right. That's the 20 gauge that I was using. Give me 1 second, folks. $20 gauge black, 20 gauge red, and we're ready to go. So, again, our black is our negative, so we'll make all of our negative runs using our black, of course. Just finished your first Trident build and you're liking it. Sweet. Yeah, I really like my Trident. It's a really good printer. I like my 2.4s as well. They both work great. So I'm not like a one or the other. You know, they're printers. They go burr. They make cool printed things. So I don't tend to, you know, I don't want to say argue, but I don't tend to really go one way or the other. But I do like my Tridents. Trident 350 was printing really nicely. I just had a layer shift through a long print, which annoyed me. And it's downstairs right now, and it makes a hell of a racket. Because I've got the bento box with the, you know, it's the larger bento box, and the 60-20 fans on it, for whatever reason, just are loud. They are loud. Okay, so we're going to have to be doing some screw down terminals as well. So what we're going to do is we're just going to work our way down one side. So our negative is on the top, so our VC or VCC voltage N is the one at the bottom closest to our capacitors. And all I'm going to do is I'm going to assume I'm going to have some type of cable troughing right here. I'm just going to kind of bring that out, assume that it comes down, go over, okay, about there. Give her a snip. Now I'll terminate this end and get it into the Wagos. Hey, 3D Medic Vince, how are you doing tonight? Hope everything is well for you. We are working on wiring up the VzBot. And it's a pretty interesting build because we're running 24 volt and 48 volt. And the 48 volt is only running our 5160 external drivers over here. So we are, you know, what I've done is installed the mains outlet and the mains power runs. They're long and just kind of laying here, but that's because I'm going to cut the troughs off stream. I need to, I really need to use the bandsaw to make sure I get some nice, good, clean cuts on these. But I'll do some trough cuts and, you know, measure it out, make the cuts, do the thing, and then we'll lay in some troughs in the next stream and pretty up our wiring a little bit. I'm going to leave the wiring a little long in some spots, just because that way it'll give us the ability to move things around as needed, or I don't know, it's so much easier to to have extras and just move it around in the trough or lay it in the trough. Gives you the ability to do some rewiring or swapping out some things later, like, who knows, maybe I get a wild hair up and I grab my Kraken like Nero did and put a Kraken in here. It can happen. Just going to go through and install all of my negative power wires first. So I'm fine running the nanotube gray. I think I might reprint these two in red, and that way I've got my mains, ground, neutral, ground, neutral, load. I may reprint this in white if I have white ABS. I know I have like a Galaxy red ABS. I may have some standard red ABS. So it's just a matter of printing out a couple of small parts, and then I'll be able to swap those over real fast and have some colors that are more appropriate for what I'm trying to do. We're just going to sit here and chat and do some basic wiring while we're chatting. Then we'll lay these in a trough somewhere and make it look all pretty. Hey, Pezliz, how's it going? Glad you made it here. Glad you made it. You're having a good day. I don't know if you saw, but we were rocking the zombie shirt and the Pezliz coffee mug on the last stream. You're a champ. Well, thank you. So the red wire I have here is actual linear wire. The black wire that I'm using here now is wire that I got from Tube Depot. They make a lot of like vacuum tube stuff for guitars. But this is mil-spec wire. So it is, what do you call it? Helpful on, or whatever the PTFE wiring name is. Meets military specifications. Oh, this is good. We haven't put our cable troughs in just yet because um, I'm just going to have to cut them down, and I want to make them kind of nice. So I'm going to cut them down on the bandsaw. If I try and cut them by hand with snips, it always looks like crud and doo-doo on one end. And I just want to try and make it look a little bit nicer. Because I believe this is going to have a clear acrylic back panel, so it's going to show off the wire all its glory and or ugliness. So how are you doing tonight, Liz? You up to anything special? You're going to be streaming later on tonight? Sorry, I keep throwing my head in the way. There's no easy way to really do it other than that. So once again, I am choosing to do ferrules into the Wagos. It is not required. You do not have to do this into the Wago side. Definitely need to do it into the screw down terminal side, and then when you screw them down, give a little tug. Same thing when you put them in the Wagos, give it a little tug to make sure it doesn't pull out. And, you'll be good there. So this is the negative side. We need to pull a negative from our power into here. So that would be the next run. So that means we're going to need a port connector on one end. So I said I wasn't going to need them. Put them over there. Or make sure you give it a tug. And our positives here, negatives here. Going to because we're only going to have the one connection on here for 48 volts, and I don't really anticipate having to do any other 48 volt off of this. I'm going to put these side by side. do this probably a little bit more than it needs, just so that we can have the ability to move these around. If I wanted to, I can fold it up some in the whatchamacallit, wire management troughs. You're back? Okay, tugboat. Now, are you doing any of the driving on your trip, tugboat, or are you just riding along? Uh-oh. That's not good. Okay, so there's the negative side. Now we're going to go through and do the positive side. Again, we're using 20 gauge wire here. For the length of these runs and the amperage, 20 gauge should be perfectly fine. And these wires are not, they're not moving. So you don't have to use the PTFE wire like I'm using. You can use silicone wire just as well in this application. Hey, Da Vinci. Yep. I do have an affiliate code out there for Polymaker Filament. Don't sponsor me or anything, but I do have an affiliate code. Maybe we'll change that later this year. Dang it. Looks like we have an ad break going on. For those of you that can still hear my voice, thank you for subscribing to the channel. Sure, we'll wind up moving these right up next to each other and making sure that we've got plenty of room. So Pez Liz, or anybody else that's out there, but I know Pez probably has it right off the top of her head. What's the countdown to Murph? Because we got to get this build and the black box build done and running before Midwest. These two printers are going to Midwest. Hey, Westery, how you doing, sis? Doing good. Hope my little girl Mia's doing well. Hope you are doing well. We are working on the wiring here for the VzBot. This is very reminiscent of the ended stream early due to stream. Mia's good, just had a hot. Okay. Yeah, we started off the stream working on our 110 voltage, so our mains voltage. So we got our switch installed, we got the wiring plumbed for both of our power supplies. We have a ground going to our SSR. I have not run anything to the bed just yet. But we did install the Wago mount for underneath the bed so that we can have an easy on, easy off, quick disconnect for the bed. But we haven't installed the bed yet. That'll happen here probably next week. We'll be at that point where we can do the actually mount, put the bed assembly together and get it mounted on the printer. Storm, okay, no, that's good. You stay safe in the storm. You've got a history of things kind of falling apart during storms. Or they're playing Little Miss Riding Hood, and the wolf keeps coming and blowing your house down. Hey, Avidus, how's it going? Like I said, some of this wire looks long. That's because I haven't put in the wire troughs yet. This one, I need to cut them to length. And rather than try and just snip through them, I'm going to cut them on the bandsaw. I'm just going to measure out, figure out what the lengths will be, cut them on the bandsaw. That way I can get them. I think I'm going to run one long one here. I don't think I'm going to run a long one here because I'm going to have 24 volt that comes up to this whole pod right here. And then that's going to be kind of a straight little jumper right there. There's no sense in doing a bunch of cable trough here because I'm going to have these come up. This one's going to come down right here. Our motors, I think, will be coming through these holes in the end, and the X and Y1 motors will come through here, up the cable trough and plug in. The two from this side will come from down here around the cable trough up and in. This is right here just for mock-up purposes. I don't think I'm going to run this. I think what I'm going to actually run is an actual Big Tree Tech Pi versus the CB1 on a Pi 4 sled, because this still requires 5-volt in, and the Raspberry, or excuse me, the Big Tree Tech Pi board can take a direct 24-volt in, and with the 24 power supply here, I can just go right in. And I think that'll be a little bit cleaner, and I don't have to worry about pulling 5-volt from something over here and adding additional. So I think that'll be easier. It would look better if it's on your desk. I gotcha. I gotcha. So I think this one, so the plan is I'm going to bring the VzBot, the black box, and the K3 are coming with me to Murph, and other printers. The Annex Engineering K3, the VzBot, and the black box are going to come home with me. The other printers that I wind up bringing, I've been known to trade printers for things. I've been known to give printers away. I've been known to sell printers. So if you're interested in a Digital Dragon build, maybe be on the lookout. If you're going to Murph, but yeah, certain ones are not going anywhere. They're going to stay here with me, like Iron Dragon over here in the corner with my custom side panels. That goes nowhere. That will go nowhere. But yeah. Mrs. Dragon's probably like, you want one, you can take one. I'll ship it. I'll figure out, you know. So, we might do that. We might just have to auction off a printer here or there. So I will tell you guys that I made a couple of posts on Twitter or X or Twix or whatever we want to call it. I did get my Milo CNC mill kit in today or yesterday. So we do have Milo in the Dragon Den. Sort of. It's in the house. It's downstairs. I can't bring it up here just because I've got too many projects going on up here right now. So I don't have the room, and I know I will step and fall over it. So it's staying downstairs for now. I still have to print all the parts anyway. But yeah. So the Milo mini mill will be here. We're probably not starting that until after we get back from Murph. Because like I said, I just have to get this done. I've got to get Black Box done and get it working and moving. I know I'll have people at Murph that there should be, KB3D will have his, I'll have mine. Hoyty will be there with his. There should be at least 3, if not more, black box tool changers at Murph this year. Oh yeah, I'll have a maker chip as well. I'll have a maker chip. But yeah, if I'm giving away printers, it'll be for specific purposes. Like I'm not just gonna walk in and say, you get a printer and you get a printer. I want to make sure that they're going to good homes and that they'll be appreciated. Digital Dragon Oprah. Yeah, that would be bad, huh? That would be bad. But yeah, there'll be some things there that will have options for new homes. I don't want to, call anything out or make any promises just yet because we got to see how much room we got in the cars to bring things. But yeah. Okay, so one side gets a ferrule, the other side gets a port connector. Here. Ripping out these port connectors is always kind of a pain. I'll bring you guys back over to the stream so you can see what I'm doing. Now I've got all these wires here. I need to undo a screw terminal. Hey, Zombie, how's it going? Yep, we're making progress on the VzBot here. And you've been making progress on the door on Velta, right? I have not punched it yet. No, it's been really good. I haven't had to beat it into submission yet. Once again, this is all of our 48-volt wiring here. This is 20 gauge wire. I will be putting some trough in here. I just need to measure it out and cut it. And I'm going to cut it with the, excuse me. I'm going to cut it with a bandsaw so I get a nicer cut like this versus whatever the hell somebody did here that jankified it. So I'm going to try and cut it nicely and in such a way that it's a little more uniform. Like right here at the bottom, this would go all the way across, but it won't go all the way across up here. So I'm going to wind up having to cut it anyhow. And yeah, I'm not sure. There may be some trough up here. There may be a vertical trough here. I don't know if there's going to be any troughing right here. I think I'm just going to come out and slap it down or something. I know in Vez's diagram, he had all kinds of trough going everywhere. And yeah, I'm not going to be that worried about it. Hey, Frosty Bite, Urban Monkey, welcome in. Thank you for the thank you for the follow. No face, no case. Welcome in. You're working on that some more tonight. Now, I know you had at least one issue with the CAD files being, needing some adjustment or being wrong with fitment and stuff. Have you had to make a lot of adjustments or? So we just ran our positive and negative for each of our 48-volt connections. Been good. I know you had the top of one upright that didn't have like a cutout in it and it was fouling against another printed part, but probably be really easy to fix. Now I did this for all the 5160. Now, one last important step to do is link your 24 volt to your 48 volt like you see below. I used a piece of wire to connect my 24 volt negative Wago to my 48 volt negative Wago. If you forget this step, you can have issues with your 5160s once we try to start using them. Okay, so give me 1 second. So we need to jumper our 48 volt and our 24 volt grounds together. We need a common ground between everything, and not just a common ground for the mains, but a common ground on the DC side as well. Cool. So I'm going to scroll back up here just a little bit. Because I was like, okay, I'm not going to do the DC stuff for the SSR just yet because I don't want to run the wires for the bed just yet. And then I realized, oh, I skipped like the entire 24 volt side. So we need to make the connection for our bed to the SSR. And I want to make quick and certain which way is which. Easier to just take this off. See the writing easy. So I have negative on this side, positive on this side. And the one thing that we want to do is put this sticker on our cover because it actually shows you the which terminals are going to what, and as well as the, oh yeah, by the way, they've got some I was going to say spades, but port connectors in here. We may use those instead of our own stuff. Okay, so what was I doing? Oh, our sticker. We need to kind of get our sticker on there sooner rather than later so that we don't make a mistake and plug things in the wrong direction. As I just dropped said sticker. No idea where it went. Oh. Yeah. It looks clean right now, but once I start doing the wires for the motors themselves, because they're not a DuPont or a JST connector, they're screwed down. So it's going to make that wiring on the right-hand side even more convoluted. But the FPC cable I don't know if I like that better than the older connectors that used the JST connectors or not. Um, just a tiny bit too big. So we've got the bed out to this piece, so we're going to need to do some bed wiring. Like I said, they're using blue and black. The funny thing is the only wire they gave me in the kit was blue and red. They did give me some blue and black, but it had big terminal connectors on it already, which made absolutely no sense. And I just kind of was like, okay, that's great. Noted, moved on. And we just grabbed our own wiring. Yeah, this is what they had in there. And I decided to use my own wiring instead of theirs because I couldn't tell if this was like, I think this was supposed to be meant for the switch wiring because that's the only thing that would take spades. But it doesn't make sense. So anyhow, so once again, we're going to go back to black for negative. So let's go ahead and connect in all of our negative wires. And I may have to redo the ground or the negative wire over here just to basically make a daisy chain between the everything. And get a bit of black wire out, and we're just going to go ahead and start connecting it up and making the connections one at a time. Thanks for the lurk, zombie. So in this particular instance, these wires are going fork to fork. So we're just going to get it laid in there. We'll do the terminal. And once again, this is going to go right here. I don't want to have a super duper amount of length. May slide sideways a little bit, but not a whole heck of a lot. Cut that short, and we'll have to put another spade on this side. Say that, but just for ease, doing this crimp. Hey man, all these people keep spilling their coffee. It's they probably spill their drinks at parties too. All right, this is going to be the negative side. There we go. We're negative to negative. Back that. Do the same thing for our positive down the road, but for now we're just going to keep doing all of our negatives. And I believe you set input voltage selector switch on your PSU if applicable. We did. Motherboard or the MCU only gets 24 volts. So everything here is going to be 24 volt. And right down here. So, and we've got to populate everything. So the bed has to have an input in order for the output to work. So you can still get the bed to work if you don't run power into the bed input, but you're having to trigger it off of another PWM slot. You can't trigger it off the bed out. You'd have to trigger it off something. Positive. Negative, negative. And I like how they do this board. They're basically putting the negatives and the positives side by side. So I've seen that done on several other boards as well. It's not unique to Mellow or the Fly board, but I do like how they do that because they're making sure that you've got good separation between your negative and your positive. Shouldn't arc because you're connecting them. So positive, yeah. It's negative, positive, positive, negative, negative, positive. Now we go negative, positive. For the most part, for the major items, you're adding separation between them. And so this is bed out, bed, and then your board and heater. So your board then the next one will be for the actual heaters themselves, the drivers themselves, and you'll have both a high and a low. We are going to populate both. Even though our 5160s are pulling from the 48 volt, we still need to be providing 24 volt on the high side, which is the top 5. We've got to provide some type of voltage, otherwise these just will not talk. We need them to talk to the 5160s, but the 5160 drivers themselves are pulling power from you. So think of the 24 volt on the low, which is the right-hand connector, does these first 3. The high does the next 5, and it's providing power to these boards, the stepper board, then communicate over the FPCs to these. That makes sense. skip one and yes, my rook will be at Murph. I might have both of them because I've cut the frame to build a completely second, separate rook rather than tear the first one apart. I think I have everything I need, and if I don't, then I'll order it to get it in. I would just say I would like to have them both rooks there. I'm not going to guarantee 100% for sure that I'll have both of them there. But that is my desire, is to have both of them there. I'm thinking I know what I'm going to do, and that may be take the other rook that I have here at the house apart. Use that one to build the Mark II, and then take the Rook 2020 and rebuild it. Maybe take that as well. I don't know. I've got goals. I've got goals and not a lot of time. Okay, so there's our 4. Come down. We'll need to supply the power to these 4. And then once again, this ground, when we go to make the run from the 24-volt power supply, we need to bring it over to here, and then also make a jumper from here to here, from here to here. So I may be redoing, taking this wire out and redoing to make like one big jumpery thing. That makes sense. yeah, the turnaround between the two shows is pretty darn quick, and then so is the you know, because it's the end of June to the end of September. July, August. Well, I guess I'll have time between um, Murph and 3D Printopia, but I've got to finish 2 droid builds for 3D Printopia. Sitting here thinking to myself, I'm doing all this with 20 gauge wire, which, like I said, should be good. So as I'm sitting here thinking about it, I'm talking to myself as to whether or not I want to do 20 or 18 gauge. Late decision to make. Okay. Went down, round, up, somewhere about there. Yeah, that's why I was asking Pez Liz earlier if she was on here so she could give me a countdown, because I know she'll give me a countdown of what we're looking for to get to Rocky Mountain. Or not Rocky Mountain, Murph. 29 days. Oh. Okay. Excellent. Need to do. Like, oh, I just need to replace this. No, I don't need to replace this completely. I just need to snip that end off. Strip this side. Put it with this strip. Maybe Bexy will go home with a printer. You know, it's possible. It'd have to be a small one that she can take on a plane with her. So now my negatives are combined between the two. I need to do all my positive sides now. "29 days. Not like you're trying to give me a complex here or something, Pez. Are you ready to go yet, Pez, or are you still freaking out? I'm gonna be like, I'm just shopping for candy and stuff for everybody. Really need to do, because I know there's an app, and I used to have like a countdown app on, it was Windows, that would just track the, track a countdown to an event. I just need to do that so I can have it up in a window so I can just freak out every day when I look at my computer. Now, the good thing is we've got a long weekend coming up. The bad thing is we've got a long weekend coming up. And I say that because my family is going to be like, oh, come down, do this, do that. And it's like, I've got things to do. I will be ready. So that means he is not currently ready. But then again, are we ever fully ready, Liz? Because I know I get to the stage where, okay, I'm as ready as I'm going to be. Ready as I'm going to be and as ready as I'm going to get. You ready to watch videos? I get that. Once again, our bed out is being connected to our SSR, which is just a big, huge relay switch, solid state relay. And so what we're doing is we're only going to use a small amount of voltage to trigger this. Hence why we don't need a lot of big gauge wire here. We're just triggering it. We can even get away with a 24 gauge for that trigger wire. Like talking myself out of continuing with, go ahead and switch over 18, at least for the power stuff coming volt. And I may switch the power on the other side. I don't know. We'll see. 20 should be fine mathematically. $20 should be fine mathematically. Every once in a while I go, hey, I'm doing a stream. Should be fine mathematically. For the length of runs that we're doing, the amount of current that it's going to be pushing or pulling, and stuff like that, mathematically it works out. But every once in a while, it's like, I know somebody's probably going to call me out on it. So go ahead and at least switch it over here. Project printer stands creeping along. Okay. Little by little, you know, you don't have to do it all in one big go. It's like here, progress was made. Don't have to be done. We just have to have progress. Okay, these are coming over there. Give ourselves some extra room. So how much more do you have left on Project Printer Stand, Timur? I know you said you're putting it on a steel base. Is it a welded steel base that you welded, or one that you bought, one that you... How'd you go about getting it? Folks, it's, oh, I just realized it is 10 o'clock. That's why I seem to be losing everybody. It's getting kind of late. So we've got 2 more wires to do, or 3 wires to do. So we need to connect these last couple of wires into the board and then make the jumper back to the power supply. We'll have all of the main power cables run. For the 8 printers in your office, about 90% done. For the 20 printer room in my Swanson hut, 20% complete. They were welded up by you and your 13-year-old grandson. Well, that is awesome. Thank you for taking the time to show your grandson how to weld, or he's taught you how to weld. That's even better. Okay, so one last one, and this is going to be our connection from our power supply over there. This will get her done for the night. We'll come back on the next stream, which will be Tuesday for this build. And we will continue on wiring stuff up. In that case, we'll have the power done. We'll just need to connect everything into the board. We'll get to start running all the other wires and doing some wire management. Good old fun time there. Remember on this side, or on the 24 volt side, we're going to run, a full set of wire, positive and minus, to the Raspberry Pi, or excuse me, not the Raspberry Pi, to the Big Tree Tech Pi that we're going to install. So it'll be ready to go as well. So I may do that part off stream just because. I mean, it's wiring. Nothing we haven't already done. We'll do this last connection and then we will get ready to head out for the evening. 10 o'clock, so that hedgehog guy should be on. memory serves me right. So, do we want to? We'll walk through our DC wiring real fast just to make sure that we've got things in place in the right or in the right places, and we can, I don't know, flip the switch on the board and make sure that we're getting power to everything that we've applied power to. There's no actual like connection to stepper motors or anything like that, so there's no opportunity. If we blow anything up at this point, it's going to be just the Mellow Fly Super 8 board, and I guess potentially some 5160s. But the good news is we got a Kraken, so we have a backup plan. That's good. That's pretty good. But it's funny how we always teach people and they do better than us. Could be that they're just being more careful. Could just be that they're just better at it than us. That happens sometimes. So I'm gonna clean some stuff up here. And like I said, I'm going to ask the question, do you guys want me to hit the power switch one more time and see if we get lights on the board and all that jazz, or are we going to hold off for the big shebang later on? I guess last chance to see me either dump a bunch of connectors everywhere or watch Sparky Sparks. Never rush power up. Well, I'm not necessarily rushing it. We are actively looking. Big shebang, big shebang. Okay. So on stream tonight, just to kind of rehash what we did, we installed our power inlet, we wired that up, and we wired power to both of our PSUs. And we validated, we ran that, and we ran the ground to our SSR. Then we powered up and we validated that we were getting lights on both PSUs. We brought the multimeter out and we checked and we're getting 48.2 and 24.1 volts. So our voltages are good. Then we did some continuity check because once again, we're grounding, but these are plastic, not a metal. So, the Wagos are not grounding anything. We've got ground to Wagos. We come out of there to a ground to our SSR. And because our SSR is grounded to a metal mount, which is attached to a DIN rail, and the DIN rail is attached to the back plate via screws and nuts, we checked and we have ground continuity between power supplies, both DIN rails, the back panel, and the base panel, as well as a little more resistance, the actual build plate. So we're grounded. The only thing I couldn't get a ground on is the frame, the aluminum extrusions themselves. But the aluminum extrusions appear to be painted or powder coated. So regardless, they're not conducting. right? And we're going to have ground going to the bed. So everything that's running mains voltage is properly grounded, and we validated that it's, so we're still good there. We've run power and ground to our 5160s, and that's tied to our 48 volts. We did a jumpered ground from the 24 volt to the ground for all the 24 volt plugs, to the ground on the 48 volt, to the 48 volt power supply. So everything's connected via a common ground. And that was a statement that was made down here. So we ran all of our 24 volt ground or 24 volt power and ground. We connected the bed out, positive and negative, to the positive and negative side of the SSR. The only other thing we're going to need to do is do a load to the SSR, and then from the SSR out to the bed. And then the neutral is going to come back to the neutral in the Wagos. Yep, we saw a spot for those, as well as a ground to the Wagos. That. Got the power run for the 5160s. And then one last important step to do is to link your 24 volt negative to your 48 volt negative. Like you see below, use the piece of wire to connect the Wago negatives to negatives. So, and if you forget to basically make a combined negative to negative between your 24 and 48 volts, then you'll have some issues with the 5160s. That's because the ground or negative for the board is different than the ones for the 5160s, and you'll have a you could have some noise generated in the, keeping everything on a common ground, both for the mains and for the DC side, we prevent any additional noise in the system. Because all the earth grounds and all the negatives are connected. Next up is we'll be in a position where we start plugging everything into the boards. This is where we're going to bring in our motor wires, and then we'll do ferrules and screw down everything on the motors. Everything over here, which will be the fans and all the other connections, go over here on this side. Like when I do the, yeah, so this is on a metal mount, which has a wider footprint. When I do the Big Tree Tech Pi, I'll be able to move it over a little bit more, which will give me an opportunity to put a cable trough right here that we can manage the umbilical stuff and stuff coming up probably. So we'll probably have a trough over here, a vertical trough over here, and then that's going to be it. I'm not going to worry about a trough right here. You know, it doesn't make sense for me with the small jumpers that we have. So a horizontal at the bottom, two verticals. They show one going here. I really don't know if it's worth putting one here. But we'll see. But cool deal. I think we're good for the day. Like I said, I'll mock up the Pi 24 volt and get that mounted. The Big Tree Tech Pi, I will get one of these mounted and on here on the board. Then we'll be able to continue with the fun when we get back. So, all right, everybody, let's find our raid target for the night. Like I said, I have a feeling it's probably going to be that zombie hedgehog. Because I want to check out the Doron Belta myself. Falls on. game. Babe Ross doing some more thing. Maker Deck. Brillo, who's actually in front of the camera. Big Jano, right, it's Thursday Marble Races. Looking at new printer board. There's a Zombie. Been going for just a little bit. We're going to go ahead and get going over to Zombie. So, all right, everybody. Thank you for being here. Thank you for checking out the stream with me and hanging out with me. We're making some progress doing our wiring. We'll come back and see everybody on Saturday morning for the next stream, where we'll have this back on the floor and we'll have the black box back up here, getting close to starting to do some more of the commissioning process. So join us here Saturday morning for the black box. And with that, take care. Let's enjoy the raid.